We will discuss now about differentiation of trigonometric functions. Now, what you always have to remember whenever you need to get or find the derivative of a certain function, then we'll just have to carefully follow the differentiation formulas. So for trigonometric functions, we will proceed to using the formulas, differentiation formulas for certain trigonometric functions. So we will have these two formulas. So when you are to get, let's say u is a function, represents a function of x, any function of x, and if we are to get the derivative of the cosine of a function of x or u, that's just equal to sine of u times the derivative of u. And if we are to get the derivative of sine of u, that's just equal, okay, let me correct this one, derivative of cosine u should be negative sine u times derivative of u with respect to x. And if you are to get the derivative of sine u with respect to x, that's equal to cosine of u times the derivative of u with respect to x. So we'll have here certain examples that we are going to answer for you to further understand how important it is to be familiar with the differentiation formulas and also the trigonometric identities, okay, because it helps us to give a simplified solution to mathematical problems. Now, okay, for these examples, we have given functions. We are to find its first derivative of x. So we have functions f of x. We are to get f of x prime and f of a prime, meaning we are to get the value of the first derivative when x is equal to a. Okay, so for the first question, or for the first function, you have f of x equals x cosine of x. Okay, so to solve that, let's rewrite f of x equals x cosine of x. So what we have to remember is that a trigonometric function, okay, is always should always be together. You could not distribute, okay, you could not just you could not treat trigonometric functions as algebraic functions. So in this case, we are multiplying x with cosine of x. So to get the derivative, we have to use the product rule for this one. So this will be our first factor, and then this one is our second factor. Now remember that in the product rule, okay, let's say you have two functions of x multiplied to one another, let's say u and v. If you are to get the derivative of that, okay, that's just equal to the first factor u times the derivative of v with respect to x plus the second factor v times the derivative of u with respect to x. Okay, so in this case, we are going to treat x as our u or our first factor and v as the cosine of x or our second factor. So the derivative now would be, just copy again the first factor, which is x, okay, times the derivative of the second factor, which is cosine of x. So we have times the derivative of the cosine of x, okay, then we have plus the second factor, which is cosine of x, times the derivative of the first factor, which is x. Okay, so to continue, okay, we know that the derivative of cosine is sine cosine of a function is the sine of that function. So we'll have x equals to the negative sign rather. So we have negative sine of x. Okay, then we'll have the derivative of x, which is equal to 1. Okay, and then we have plus cosine of x times the derivative of x with respect to itself. So that is an identity rule, and that is simply equal to 1. Okay, so we now have negative x sine of x. Okay, so there's just a negative 1 is multiplied to the sine of x. So you could multiply negative 1 with x and 1, so that's negative x, then multiply to the sine of x plus cosine of x. Okay, you can't do something like this. When you have x times negative sine of x, you can't multiply, you can't distribute x to the function inside the trigonometric function. So it's not, so x times negative sine of x is definitely not equal to negative sine of x squared. Okay, so that's so much of a violation on mathematics. So I need you to be careful with that. And anyway, so therefore, for the function f of x equals x times cosine of x, the derivative f prime of x is simply equal to, we'll have cosine of x minus x times sine of x. Now for f prime a, and given in our problem is that a is equal to 0. Okay, so we'll have here f of 0 is equal to, f prime of 0 is equal to cosine of 0 minus 0 times sine of 0. Now, any value multiplied to 0 is always 0. So we'll have cosine 0, okay, minus 0, or we have cosine of 0. Now, the values of the variables here, if they are to be used to trigonometric functions, then they are treated as values in radians and not in degrees. So if you are to get the value, let's say for cosine of 0, that's simply equal to 1. Okay, we know that. But when we are going to use the calculator to get the cosine of a trigonometric function of a certain value, okay, we need to set our calculators to radians. So if you don't have yet an updated calculator, okay, you must have one, because when you're going to take the board exam, you need to have your own updated calculator that is allowed to be used in board examinations. So today, this is 991 ES plus is not allowed, as what I heard. But what is the most updated and the allowed calculator that I want you to have right now para masanay mo magamit is 570 ES. Okay, so I need you to have that one, 570 ES. So anyway, we'll have, if you are to set your calculators to radians, you just press shift and then you have mode. Anyway, the 570 ES and this 991 ES plus almost have the same features of its calculator. So anyway, then you wanted to use radians, so you just press 4. Okay, so this is now set in radians. So you have cosine of 0, that's of course equal to 1. Okay, so the answer, f prime of 0 is equal to 1. Okay, So these are your answers. Next problem. Okay. We have f of x equals 3x cosine of times cosine of x over 3 minus 9 sine x over 3. Okay, and given that a is equal to pi over 3 radians. Okay. Sorry. Okay, so first, getting the first derivative. Okay, what we are going to do is that we have, in this function, we have two terms. This is our first term, and this is our second term. Okay, we know that terms in a certain polynomials or functions, terms are separated by a minus or a plus sign. So in this case, you have this first term and then the second term. So in addition rule for differentiation, remember that if you are to differentiate the each of the terms individually. So in this case, we are to get the derivative. We are first getting, or we should first get the derivative of this first term, and then after that we get the derivative of this second term, and we'll just combine. Okay, so in this case, for our first term, 3x times cosine of x times x over 3, we will treat this as our first factor, and cosine x over 3, we will treat this as our second factor. So for the product rule, we know, so we'll just copy the first factor and then times the derivative of the second factor, which is cosine x over 3, and we know that the derivative of cosine is negative sine, so we'll have negative sine of x over 3. Okay, and then you get the derivative inside the trigo function. So you have x over 3. X over 3, okay, is simply multiplying 1/3 with x. So the constant there is 1/3 and then multiplied to the variable x. So therefore, derivative of a constant multiplied to a function of x is just equal to the constant, okay, which is 1/3 times the derivative of the variable x, which is 1. So we will just have 1/3. Okay. Next, you have next is we will plus, we copy the second term, which is cosine x over 3, and then just we must enclose this to parenthesis, and then we will have the derivative of 3x, which is simply equal to 3. Okay. Now, we have to emphasize these parentheses because if we don't have a parenthesis here, then you might be confused as multiplying x over 3 with 3 directly, which is wrong. So, next we are done getting the derivative of the first term. We will now get the derivative of this term, negative 9 sine of x over 3. In this case, you have a constant negative 9 multiplied to a trigonometric function sine x over 3. So we know how to deal with the constant multiplied to a function. We'll just copy the constant, then times the derivative of the function. So we will simply copy the constant negative 9, and then times the derivative of sine x over 3. Now, the derivative again of sine is cosine. So you have times cosine of x over 3. Then we will again enclose it to parenthesis. And then derivative of x over 3 is simply 1/3. Okay. Sorry, I must omit this equal sign. So this is continuous, this equation. So we now have, okay, so we could cancel 3 here. Okay, in this case, we now have negative x times sine of x over 3. Okay, next is for this term, so we have plus 3 times cosine of x over 3. Okay, and then for the last term, you have 9 over 3. That's simply equal to 3. Okay, so we now have negative 3 times cosine of x over 3. Further simplify, 3 times cosine x over 3 minus 3 times cosine x over 3 is equal to 0, so you could cancel that. And then, finally, we have first derivative of the given function is equal to negative x sine of x over 3. Okay? And then, f prime of a, which is given to be pi over 3, is equal to, okay, we could use the calculator for this one. We have negative, you can do something like this, negative, okay, pi over 3. Then again, that's sine of x over 3. Okay, so our x here would be pi over 3. Substitute x with pi over 3, and then, okay, could you see that? And pi over 3 times sine of x, okay, which is pi over 3, or pi divided by 3, then divided by 3. Okay, so it is very important to set the calculator to the radian mode, because if it was set to the degree mode, it will treat this function as in degrees and not in radians. So we'll have, so the answer, we have negative 0.358. Alright, here you go. You could actually use something like this. We will just copy first the function itself. So that's negative. Then we have here x in this button. At the upper portion of this button, we have a red letter, letter x colored red. So we could choose that by simply choosing alpha. Alpha is in color red, so we'll have alpha, and then this button. So we have the variable x. Then sine of, we have alpha x over 3. Okay, and then we will press this one. Instead of pressing equals, okay, we should first press this one if we are using variables in our calculator, and we will just set a certain value for that variable. Okay, we will just use this, press solve. Okay, actually the button here, it's written calc, so this calculator is too old that some of the letters here are erased. Anyway, so it will be asking for a value of x, and for this case our x is pi over 3, so we'll just have pi divide 3, or pi over 3, and the press equals, show negative. So this is helpful if, let's say, we need another value of x. Let's say we get f prime of pi over, let's say, 4. Okay, so we already set this expression, so we'll just press calc, okay, so that we could set another value for x, and that would be pi over 4. So we simply have pi over 4. So we already have negative 2.03, 0.203. Okay, so mas madali siya kesa i-type mo na naman siya ulit. Let's say you have negative pi over 4, ganun, no? So ita-type po pa siya ulit. So mas maganda yung ganun. So that's one of the features of the calculator. No, it's how to use variables or letters here in the calculator. Actually, you could use any letter. Let's say you wanted to use a, so you have negative alpha a sine of, you have fraction alpha, then a over 3. So just be careful with the variable that you're going to use, and then use press calc. Okay, and it will be asking for a value of a, let's say pi over 4. So you will yield the same answer. So it's up to you. Okay, next. We'll have number 3. Okay, we will use another sheet of paper. Okay, number 3, you have the function f of x equals sine of x times the quantity cosine of x minus 1. And we'll have, okay, f of x equals to sine of x times the quantity cosine of x minus 1. Given that a is equal to pi. Okay. Ito na. Okay, so in here, since this quantity here is inside a parenthesis, therefore this is counted as one factor, and then this is also counted as 1. Okay, so we could use product rule. So this will be our u, or first factor, and this will be our second factor. So again, we'll have f of x prime is equal to derivative of the first factor, which is sine of x, times first factor sine of x times derivative factor of this derivative of the second factor cosine of x. That's simply negative sine of x. Okay, then plus 0 because negative 1 is constant. Derivative of that is 0. So we'll have, close it to parenthesis, and then we'll have plus, we copy the second factor, cosine of x minus 1 inside a parenthesis, and then times the derivative of the first factor. So sine of x derivative is cosine of x. So we'll have negative sine squared x. Okay, so this is what's going to happen when you multiply, okay, two same trigonometric functions. Okay, you could actually do something like this. You have negative 1 multiplied, so you have negative sine, and then you have sine of x that is raised to 2 because we have sine of x and sine of x multiplied to each other. Or, okay, and then next you have, okay, let's proceed. We have plus, okay, we could now distribute this one. Okay, so this is counted as 1. Okay, just multiply it with the first term inside this quantity, then again you multiply it to second term in this quantity. So this is also counted as 1, and this term is also counted as 1. Okay, so you have cosine of x times cosine of x is cosine of x raised to 2, and minus cosine of x times negative 1 equals negative cosine of x. Okay, so we now have, okay, this is just equal to negative sine of x squared. Okay, so dito mo siya sa sine na function erase, and that would mean that the entire trigonometric function sine of x is raised to 2 because it's sine, let's say sine x squared is totally not equal to sine of x squared. Okay, so you should not be confused with the two. Okay, next you have plus cosine of x squared, okay, minus cosine of x. Right. Now we could actually use here a trigonometric function. Okay, we have cosine squared of a function minus sine squared of the same function, which is x, trigonometric function. Okay, you have cosine squared of u minus sine squared of u is equal to cosine twice of the function u. Okay, so we have this one, cosine squared of x minus sine squared of x is simply equal to cosine of x multiplied to 2. Okay, so the function here, you just, inside the trigonometric function, you multiplied it to 2. So that becomes cosine 2 of x, 2x. Okay, then we have simplified these terms into cosine 2x, then we have minus cosine of x. So this is a more simplified way of expressing the answer. Okay. Okay. Next is we get the first derivative if x is equal to pi. Okay, so just have this cosine, okay, 2x or 2 times pi, because a is equal to pi. We'll have 2 times pi, okay, then minus cosine of x, which is pi. Okay, 2. So the answer is 2. Okay, you really have to be careful. Now, pi radians, okay, pi radians in degrees, that's how much? Okay, pi radians in degrees, that is 180 degrees. Okay, so if you are going to use a value of an angle in degrees, then you should first set your calculator. You have shift mode, and then it should be in degrees. So that's number 3. Okay, so nakaano na siya ha, shift mode, and then you have number 3. So naka-degrees na ito. So pag naka-degrees na, yung value of x, which is in radian, which is pi, you can't use this value anymore. Kailangan naka-degrees. So what we should use is 180 instead of pi, because our calculator is in degrees mode. So you have cosine 2 of x, and x is equal to 180 degrees, then minus cosine of x, which is equal to 180 degrees. Okay, so you have the same answer, 2. Ngayon, I will just show you how much it differs if you got it all wrong using the calculator. So if you are going to use the value of x in radians, or the value of the angle in radians, and your calculator is in a degree mode, how do you know that it is in degree mode? Dito we have letter D right here. So meaning that it is in a degree mode. So if you're going to use value in radians, that calculator will treat it as in degrees. So pi is equal to 3.14. So the angle here in the trigo function is 3.14 degrees, which is not equal to 180 degrees, definitely. So it's equal to, you will be given a very different erroneous answer, so you have to be careful. So if you're going to use the angle in radians, then you have to first set the calculator in radians mode. So you have shift, and then mode, press mode, and then number 4, that is radians. Okay, so ito, you could see here, di lang masyado lang blurred. Yan. Okay, dyan, you have R. That means the calculator is in radians mode. So, naka-radian na, and then naka-radian na rin yung inyong angle dito. We have press again equals, then it will give you the right answer. Okay? Okay, next. Number 4. Next function. Number 4, f of x is equal to sine 5x lang, basta kamay ko. Okay, and sana. Ito, number 4. Sine 5x minus 1/3 sine 5x cubed minus 1/3 sine 5x cubed. Okay, and the value of a is pi over 5. Okay. Okay, answer. So we will first get the derivative of the first term. That's sine of 5x. And then we'll get the derivative of the second term. That's negative 1/3 sine of 5x cubed. Okay, so sine of 5x. So derivative of sine, it's cosine 5 of x. And then times the derivative of 5x inside the function, a trigo function, that's 5x. So you have the derivative of 5x is 5. Okay? And then you have negative 1/3 constant times the derivative of sine 5x cubed. So in this case, sine of 5x cubed, in getting the derivative, this is our trigo function, just sine of 5x. Now, it is raised to an exponent of 3, and we could actually use power rule. Okay? So in power rule, if you could still remember, you have the derivative of, let's say, of any function of x represented by u raised to a numerical exponent n. A derivative of that with respect to x is equal to, you bring down the exponent n times the function raised to n minus 1, then times the derivative of the base, which is u. Okay, so you have du over dx. So in this case, if we are to get the function of sine, we have sine of 5x raised to 3, sine cube 5x. Okay, that's equal to, we treat here u, sine 5x is u. So we have n here is 3. So you have 3 times u, which is sine of 5x. That is raised to n minus 1, or 3 minus 1, that's 2. Okay. And then we have times the derivative of u, which is sine of 5x. Okay. Next, we are now going to get the derivative of sine of 5x.